Look, in this company, we are used to do two things. Number one is to do what we claim we are going to do, to keep the promise. And the second is to see to manage things when they happen. We are looking at that. We are trying to understand what is going to be the percentage.
This story begins with one of the most extreme cars ever built, the Bugatti Chiron Per Sport, a machine worth around $6 million and made in very limited numbers. Only about 60 units exist in the entire world, which makes it more exclusive than most private jets or luxury homes. This is not just a fast car. It is a symbol of engineering perfection. It comes with a massive quad-turbocharged W16 engine, advanced cooling systems, and hand-built carbon fiber parts that take months to complete. Every detail is checked by experts before the car leaves the factory. But despite all of this perfection, one accident in Miami changed everything. The car was badly crashed, leaving the front end destroyed, airbags deployed, and critical internal parts damaged beyond normal repair limits. Bugatti itself reportedly declared the car unsalvageable, meaning it should never be fixed again. The insurance company agreed and officially wrote it off. The car was sent to a salvage auction, a place where damaged exotic cars are sold for parts or forgotten completely. At this point, most people would see a dead machine, something too expensive and too complex to ever return to the road. But this is where the story takes a shocking turn. Instead of being destroyed or forgotten, the wrecked Bugatti became the center of one of the most controversial rebuild projects in automotive history. A British YouTuber named Mat Armstrong saw the wreck and made a decision that shocked the entire car world. He believed the impossible might still be possible. This was not just about fixing a car anymore. It became a challenge against one of the most powerful car manufacturers in the world. A battle between a small independent workshop and a company known for building the fastest and most advanced hypercars on the planet. From this moment, the story was no longer about a crash. It became about whether modern engineering limits are real or just assumptions waiting to be broken. To understand why this rebuild became so famous, you need to understand the man behind it. Mat Armstrong is not a factory engineer or a billionaire collector. He is a self-made builder who became known for buying crashed luxury cars and rebuilding them with his own team. Over the years, he has worked on Ferraris, Lamborghinis, McLarens, and many other high-performance machines that most people would never dare to touch after a crash. His workshop is not a massive corporate facility. It is a hands-on garage where creativity often matters more than official procedures. His content shows the entire process of rebuilding cars from salvage condition to working condition, and this has built him a large audience on YouTube. When he heard about the crashed Bugatti Chiron Per Sport in Miami, he immediately saw it as something different from anything he had done before. This was not just another damaged supercar. This was a hypercar worth millions, built with technology that even experienced mechanics rarely get access to. The car had been bought at auction for a massive price, even in its damaged state, proving how valuable it still was. The owner and Armstrong decided to take on the challenge together. Their goal was simple but almost impossible. Bring the car back to life without official Bugatti support. No factory parts, no official repair manuals, and no guarantee of success. Most experts believed this project would fail before it even began. But Armstrong is known for taking exactly these kinds of risks. His reputation is built on proving people wrong, especially when something is labeled impossible. This Bugatti project was not just another rebuild for his channel. It became the ultimate test of skill, patience, and engineering creativity, watched closely by millions of viewers and the automotive industry itself. As soon as work began on the Bugatti, the situation became even more complicated. The company behind the car, Bugatti, reportedly reacted strongly to the independent rebuild. One of the most important actions was the locking of the vehicle identification number, also known as the VIN. This VIN lock meant that official Bugatti dealerships around the world would no longer provide parts or support for car. It was essentially removed from the official system, making it extremely difficult to repair using normal channels. This created a major problem for the rebuild team, because hypercars like this depend heavily on factory-specific components that cannot easily be replaced with standard parts. At the same time, the CEO of Bugatti, Mat Rimac, became involved in discussions around the situation. He raised concerns about safety and engineering risks, explaining that a crash at this level could have damaged the structural core of the car, known as the monocoque. He also suggested that proper repair would require specialized facilities capable of handling extreme precision work. According to him, only a few places in the world could safely split and rebuild such a vehicle. This created a public debate. On one side, Bugatti argued that safety and engineering control were essential. On the other side, Armstrong and his team believed that modern tools, creativity, and skill could overcome these limits. The disagreement was not just technical. It became philosophical. It raised questions about who should be allowed to repair complex machines. Should only the original manufacturer have control, or should skilled independent builders also have the right to fix them? This tension turned the project into something much bigger than a car rebuild. It became a global discussion about engineering ownership, control, and the future of automotive repair. Once physical work began, the true difficulty of the project became clear. The Bugatti was not just damage on the surface. It had deep structural problems that required advanced engineering solutions. One of the first major challenges was separating the car into two main sections. According to experts, this kind of operation is extremely risky and normally done only in specialized factory environments. However, Armstrong's team carefully disconnected wiring systems, coolant lines, and mechanical connections until they were able to split the car successfully. This revealed even more hidden damage inside the structure. The engine had been pushed forward in the crash, damaging support brackets and crushing internal components. One of the most serious issues was a broken engine mount structure made from cast aluminum. Instead of replacing it with official parts, which were unavailable due to the VIN lock, the team had to engineer a custom solution. In another section of the build, they discovered that the gearbox mount was designed in a way that allowed it to break during crashes to protect other parts of the car. This meant it could not simply be reused once damaged. A specialist technician carefully welded the broken component back together, restoring its structural strength. After this, the two halves of the car were rejoined using high-strength titanium bolts, carefully torqued to exact specifications. Every step required precision because even a small mistake could destroy the entire project. The level of engineering involved was extremely high, but the team continued step by step, solving problems one by one. What made this phase remarkable was not just the difficulty, but the fact that it was being done outside a factory environment, by a small independent team working against global expectations as the rebuild continued. The team had to create many parts from scratch because original Bugatti components were not available. This forced them to use a mix of modern engineering tools and traditional fabrication methods. One of the most impressive contributions came from a machine shop specialist who built a completely new front crash bar without any original reference part. This required careful measurement, design work, and manual fabrication over many hours. The result was a perfectly fitting component that matched factory standards. The cooling system was another major challenge. The Bugatti uses multiple radiators to control its powerful engine, and several of them were damaged in the crash. Instead of ordering replacements, custom radiators were built and installed. The engine mount system was also recreated using digital scanning and CNC machining, where a solid block of aluminum is shaped into a precise part using computer-controlled tools. Even small components like coolant pipes had to be replaced with improvised but functional solutions. In one surprising discovery, the team found that some parts, like airbags, were compatible with much cheaper vehicles, such as an Audi A3, showing unexpected shared engineering between different car brands. The interior also received full restoration, including seats, dashboard, and trim work, carefully rebuilt to match the original luxury design. Every part of the process showed a combination of creativity and technical skill. Instead of relying on factory systems, the team used problem-solving and adaptation. This stage of the rebuild proved that even extremely advanced machines can sometimes be repaired using smart engineering thinking, not just official replacement parts. After months of hard work, the most important moment arrived: the first start of the engine. Every system in the car had to be carefully reconnected, including fuel lines, cooling systems, electrical wiring, and electronic control units. The tension was extremely high because no one knew if the engine had survived the crash damage. If internal components were too badly affected, the entire project could fail at this final stage. The team carefully checked every system before attempting to start. Then, with everything in place, the engine turned over. After a brief moment of silence, the powerful W16 engine came to life. The sound filled the workshop, marking one of the most important moments in the entire rebuild. It was not just mechanical success. It was an emotional victory. A car that had been officially declared dead was now running again under its own power. This moment proved that the rebuild had moved beyond theory and into reality. The team had successfully brought back one of the most complex engines ever built without factory assistance. It was a turning point that shocked viewers around the world and even surprised people within the automotive industry. For Mat Armstrong, it was proof that determination and engineering skill could challenge even the most advanced automotive systems in existence. However, the story did not end with success. The rebuild also sparked serious debate in the automotive world. Many people questioned whether such a complex vehicle should be repaired outside official factory systems. Safety concerns were raised, especially regarding long-term reliability and structural integrity. At the same time, others praised the project as an example of innovation and the right to repair movement, which argues that owners should have freedom to fix their own property. The manufacturer, Bugatti, faced pressure from both sides, while Mat Armstrong maintained that safety and engineering responsibility must remain a top priority. The project became a symbol of this larger conflict between corporate control and independent engineering creativity. It raised questions about whether highly advanced machines should only be repaired by their original creators or whether skilled independent builders can achieve the same results. The discussion spread far beyond just one car, touching industries like electronics and medical equipment as well. Meanwhile, Armstrong's rebuild continued to evolve, with the car running and driving again, although final certification and long-term evaluation were still uncertain. Despite the controversy, one fact remained undeniable. A machine that was officially declared dead had been brought back to life. This achievement showed the power of modern tools, human creativity, and determination. It also proved that engineering boundaries are often wider than people assume. The story continues to inspire debate, curiosity, and admiration, and it remains one of the most extraordinary rebuild projects ever documented in the automotive world. Looking at the full journey, this Bugatti rebuild is not just about fixing a damaged car. It is about challenging limits and redefining what is possible in modern engineering. A $6 million hypercar, designed with extreme precision and built by one of the most advanced car manufacturers in the world, was brought back to life outside of the official system. The project showed that even when a machine is declared beyond repair, human skill and determination can still find a way forward. The work done by Mat Armstrong and his team demonstrated a powerful message. Knowledge is not limited to factories, and innovation can come from independent workshops as well. At the same time, the concerns raised by Mat Armstrong and Bugatti remind us that safety and responsibility are also extremely important when dealing with such powerful machines. The balance between freedom to repair and manufacturer control remains an open question. Even today, the car's full future is uncertain, including registration, long-term durability, and official approval. But one thing is clear. The Bugatti Chiron Sport that was once written off is now alive again, running and driving thanks to a mix of engineering, creativity, and determination. This story will continue to be discussed for years because it represents more than just a rebuild. It represents a clash between tradition and innovation, control and freedom, and limits versus possibility. After the car started and proved it could run again, the rebuild entered a new phase where everything became about testing, refinement, and trust. A running engine is one thing, but a fully roadworthy hypercar is something completely different. Every system had to be checked again and again under different conditions. Cooling systems were monitored closely because the W16 engine produces extreme heat under pressure. Electrical systems were tested to ensure that no hidden faults were left from the crash damage. Even small issues could turn into serious problems at high speed. The team also had to carefully examine the structural repairs, especially the area where the car had been split into two halves and rejoined using titanium bolts. This section of the build was under constant scrutiny because it carried the entire force of the vehicle during movement. At the same time, attention was given to suspension alignment, steering response, and braking performance. These systems needed to feel as close to factory condition as possible. The challenge was that many of the parts used in the rebuild were custom-made, which meant they had to behave exactly like original components under stress. This stage of the project was slower and more careful than the earlier dramatic repair work. It was not about building new parts anymore. It was about making sure everything worked together safely. For Mat Armstrong, this phase was just as important as the rebuild itself, because a successful project is not defined by starting an engine, but by surviving real-world conditions. The car had come back to life, but now it had to prove it deserved to stay alive as testing continued. The world outside the workshop remained deeply divided. Some people saw the rebuild as a breakthrough in independent engineering. Others saw it as a risky experiment that pushed the limits of safety too far. Online discussions grew stronger, with viewers analyzing every detail of the rebuild videos, from bolt placement to panel gaps, trying to judge whether the car was truly safe. Meanwhile, the official automotive world remained cautious. Bugatti maintained its focus on safety standards and engineering control, while Mat Armstrong continued to emphasize that hypercars require highly controlled environments for repair. The rebuild had now become more than a YouTube project. It was a real-world case study in modern engineering debate. It raised important questions about how far independent mechanics can go when working on extremely advanced machines. Can modern tools like 3D scanning, CNC machining, and digital modeling truly replace factory-level systems? Or are there limits that should not be crossed? These questions did not have simple answers. The project had already proven that repair was possible, but had not fully proven that long-term reliability could be guaranteed. This uncertainty kept the story alive long after the initial success. It also ensured that the Bugatti rebuild would remain a reference point in future discussions about automotive engineering, repair rights, and technological control. Eventually, the focus shifted from just rebuilding the car to understanding what the entire journey meant. This was no longer just about one Bugatti Chiron per sport. It was about how modern engineering systems interact with human creativity. The rebuild showed that even the most complex machines in the world are still built from parts that can be understood, measured, and reproduced with enough skill and technology. The work done by Mat Armstrong and his team demonstrated that knowledge is no longer limited to manufacturers alone. With the right tools and determination, independent builders can reach levels of engineering that were once thought impossible outside factory walls. At the same time, the concerns raised by Mat Armstrong highlighted an equally important truth. Extreme machines require extreme responsibility. When dealing with vehicles capable of over 400 kilometers per hour speeds and massive power outputs, even a small mistake can have serious consequences. This balance between innovation and safety became the central theme of the entire story. The Bugatti rebuild was not just a victory or a controversy. It was a demonstration of how complex modern technology had become and how humans are still learning how to control it safely. It showed that progress is not only about building faster or stronger machines, but also about understanding how to repair and sustain them responsibly. In the end, the story of the Bugatti Chiron per sport rebuild is about more than cars, money, or engineering. It is about belief. A car that was worth $6 million, built by one of the most advanced automotive companies in the world, was declared beyond repair after a devastating crash. Yet through determination, problem-solving, and teamwork, it was brought back to life outside its official system. The project challenged traditional ideas about ownership, repair rights, and engineering authority. It showed that knowledge does not always have to stay locked inside factories, and that innovation can come from unexpected places. At the same time, it reminded the world that extreme machines require extreme caution and that safety must always remain a priority. The work of Mat Armstrong turned a destroyed hypercar into a running machine again, but more importantly, it turned a simple rebuild into a global conversation. A conversation about what is possible, what is allowed, and what the future of engineering should look like. Whether people agree or disagree with the methods used, one fact cannot be denied. A machine that was officially declared dead now runs again. And that alone is enough to make this one of the most remarkable automotive stories ever told. Even after the car was rebuilt and proved to be running, the story did not truly end. In fact, the most uncertain part was still ahead. A rebuilt hypercar like this does not automatically return to normal life just because it starts and drives. It still has to pass a series of checks, legal approvals, and long-term reliability tests before it can be fully accepted back on the road. One of the biggest unanswered questions was whether the car could ever be officially registered again under its salvage history. Different countries have strict rules about rebuilt supercars, especially when the structural frame has been repaired or modified outside factory conditions. Another major concern was long-term durability. Even if everything works perfectly in short tests, hypercars operate under extreme stress, and small hidden issues can appear later at high speed. The team had to consider whether custom-made parts like radiators, mounts, and welded components will hold up over months or years of use. At the same time, attention from the public and automotive industry did not slow down. Millions of viewers continue to watch every update, analyzing the rebuild as if it were a real-time engineering experiment. Some saw it as proof that independent builders can match factory-level engineering. Others saw it as a risky exception that should never be repeated on such complex machines. For Mat Armstrong, the project became more than just content. It became a defining moment in his career, placing him at the center of one of the most discussed automotive rebuilds in modern internet history. Meanwhile, companies like Bugatti continue to represent the official side of engineering, where safety, precision, and controlled environments remain the highest priorities. The contrast between these two worlds ensured that the debate would continue long after the final bolt was tightened. Looking at the full journey, the Bugatti rebuild represents a turning point in how people think about modern machines. It shows that today's technology is so advanced that it creates a strange situation. Machines are incredibly powerful, but also extremely dependent on controlled systems and official repair networks. When something goes wrong, only a small group of specialists is usually trusted to fix it. But this project challenged that idea in a very visible way. It demonstrated that with enough knowledge, tools like 3D scanning, CNC machining, and careful engineering planning can recreate even the most complex components outside a factory. At the same time, it also highlighted why manufacturers like Mat Armstrong insist on strict repair control, because the risks involved are not small. This balance between innovation and safety is now one of the most important discussions in the automotive world. The rebuild did not fully answer the debate, but it made it impossible to ignore. It forced people to ask uncomfortable but important questions about ownership, repair rights, and technological control. In the end, the Bugatti Chiron Sport did something rare. It became more than just a car. It became a symbol of what happens when human creativity meets extreme engineering limits. A machine that was once written off as dead now stands as proof that even the most advanced systems in the world are not beyond human understanding. And that idea alone is what makes the story unforgettable. In the broader picture, this Bugatti rebuild is likely to influence how both manufacturers and independent builders think about future repair systems. The automotive world is already moving toward more complex, software-driven vehicles, where electronic systems, sensors, and encrypted control units are just as important as mechanical parts. In that kind of environment, the gap between factory repair and independent repair becomes even more important. What happened with this project shows that even extremely advanced machines can sometimes be recreated outside official systems, but it also shows how much risk and responsibility comes with that freedom. Companies like Bugatti represent a model where every detail is controlled, tested, and validated under strict conditions to protect both performance and safety. At the same time, builders like Mat Armstrong demonstrate a different approach, where creativity, problem-solving, and real-world experimentation can achieve results that traditional systems might reject. As more cars in the future become electric, software-limited, and heavily encrypted, the question of right to repair will likely become even more intense than it is today. Governments in some regions are already discussing laws that could force manufacturers to allow more access to repair data and parts, while manufacturers argue that too much openness could create safety risks and reduce quality control. This tension is not going away anytime soon. What makes this Bugatti story so important is that it gives a real-world example of both sides of the argument. On one hand, a damaged hypercar was successfully brought back to life using independent engineering methods, proving that knowledge is not limited to factories. On the other hand, it also raised serious questions about long-term reliability, structural safety, and whether such repairs should be widely encouraged or carefully restricted. Even Mat Armstrong and other industry leaders represent a future where performance, safety, and responsibility must remain balanced at the highest level. In the end, This story is not just about one Bugatti or one rebuild. It is a preview of a much larger future conflict in engineering. Who controls complex technology? Who is allowed to repair it? And how far human innovation should go when machines reach the limits of perfection.